Okay, hi everyone. My name is Tony, and today I'll be talking to you about the new compiler from Microsoft called Roslyn. So I already asked that question, but more people came in the meantime. So how many people have already heard about Roslyn? Used Roslyn? Okay, well, small number. Roslyn. So probably know something about it, but I'm going to have a small introduction telling you about what's the rationale behind why do we have the new compiler. Then I'm going to jump into scenarios for using it. This talk is intended to show you the benefits of using Roslyn, even as a consumer, and then as a producer of Roslyn-based components. So I'll just give you an overview of all the things you can do. I will not. There will be demos, but I'm not going to code anything because my sacrifice to demo gods was really short, and I don't want to, copy paste anything wrongly. So I'm just going to show you the demos, and they'll work because I tested them. Anyway, so first things first. What is Roslyn? So the basic, just a small side note, it's no longer called Roslyn because Roslyn was the code name for the new compiler. Now that it's done, it's no longer called Roslyn. It's actually .NET compiler platform, so this is kind of deprecated. But still, it's shorter, and we like shorter things. And you can notice the Microsoft naming convention right there. So what is Roslyn? To put it in plain terms, it's a compiler for C# and VB. It's a brand new, and it's open source. It's published on GitHub. It was previously on Codeplex, and it's under Apache license, which means you can just fork it, do your C# or D#, whatever you want to create, and you can just use it as you want. It will be present in Visual Studio 2015 if anybody has downloaded the new CTP and actually any version of the Visual Studio 2015. You have already used Roslyn, so basically. You haven't noticed really anything. Okay, and the one final thing that Roslyn is a compiler as a service, but we'll get to that later on. This whole talk is interconnected, so I will tell you things in advance and then go back to it because it's all really interconnected. So first things first, why do we need compilers? We need them to take code and create executable code, right? So if it's just a black box that you see when you press F5 or F6 or you invoke it from the command line. So if that's the real purpose of compiler, we can just work in Notepad, right? We can just write code as a text because that's what the code is. It's a text. Those are text files. You can use compiler to create object files and later on executables. But of course, we're not writing code in Notepad. Some of us are writing in Sublime, but that's another story. So the real reason for Roslyn is because the whole environment, the tooling around the language is really important. It's not the language that works for you. It's actually the tooling, the debugging, the editing, the whole experience from the first line until the deployment, and later on, if you take into account ALM. So the Roslyn is supposed to change the whole infrastructure. If you take a look at the following list, so if you take the first and most obvious thing for a compiler to do is to incorporate new language features, right? And then you want to use those features in your favorite IDE. You have to use coloring, syntax highlighting, formatting, editing, navigation, refactoring. So basically, you start from a pure language, which is text, and then you go up and beyond, and you realize that that's actually the compiler can do everything inside of that. So that's the reason for Roslyn. When it was a black box, so the old C# compiler was written in C++ and a little bit of managed code. So in this step, this magical step, where it creates code, it creates a lot of metadata, which is then promptly lost. And that metadata is really important. Why? If you take a look at what services are now part of the compiler platform, when you open Visual Studio and when you open a C# file, what do you get? You don't get the pure text. You get the syntax highlighting. That syntax highlighting comes from a component that parses the code and produces the output, which can be colored, right? So you have to tokenize it. If you ever took a computer science class where you have to create your own compiler, you know how cumbersome it is to take a language and create a parser for it. And when you take a look at the third-party editors which can do syntax highlighting, like Sublime, like Notepad++, or pretty much any editor that can parse and display C# in a colorized format, it actually has to re-implement the new language features. So when you get a new language feature, you have to redo all the components that depend on it. You have to change the refactoring. You have to change the coloring. You have to change the formatting, navigation, analysis. Everything that is tied into a language now has to be changed because you add a new feature. A few years ago, I was working on an article for a new C++ features in C++ 11, I think. And the Microsoft, because there was a conference, they published a new CTP for the Visual Studio. And it had new features in the language, like a ranged for loop, that's like for each only in C++ world. And the funny thing was that it was implemented in the compiler. You could write code, it would compile, it would work. But the editor showed you that that's an erroneous code. It highlighted it in red, said you cannot write for that way, it's wrong. So what happened there? The IntelliSense was not written by Microsoft, it was outsourced to an external company. And because they were out of sync, first they invent features, and then the IntelliSense team gets there and writes the IntelliSense. So those two components are out of sync, one comes before another. And with Roslyn, you get that in tandem, right? So when you have a new C# feature, it works out of the box. It works magically. It integrates with the rest of the environment. I'm going to show you a demo of that later on. So basically, while the language evolves, you want the tooling to evolve along with that. So this brings us to a real definition and the reason for Roslyn. It's a completely revamped compiler infrastructure. It's not just a compiler, like taking source code and compiling it. It's complete pipeline from the moment you start your IDE until you get your code and beyond. When you have features like edit and continue, you have debugging, and everything is tied into a language which is tied back into a compiler. You can see that this whole mess is actually just one huge thing, which is then partitioned into services. And the best thing that it's open source, and this gives you some, let's say magically, cross-platform features. If you take a look at the Mono project, they had to write their own compiler, their own linker, jitter, everything. But now they can just take Roslyn and they can get advantage of the new language features immediately, but they don't have to invent them as they see them. Okay, so why would we do that? Who's the immediate beneficiary? Well, all of us. So every developer benefits from a new compiler, because if you're working on a daily basis with C#, you will want new features, you'll want better tooling, you will want the whole ecosystem. That's, of course, if you're using the latest version of Visual Studio. For those stuck in Visual Studio 2008, you're missing out the whole playground. So basically, everyone is a beneficiary of this. And then the partners, the third-party people who are building third-party tools, like ReSharper, Code, any other tools that might integrate into your coding experience. Then you have the initial teams that actually work on the C#. When they create new language features, it's now far more easier to add new language feature than it was before. That's actually one of the primary reasons why they chose to rewrite the entire compiler, because they couldn't add new features. It was a whole mess. And now you can see that the C#6 comes with a whole set of small features, and C#7 will come with even more and even more. And one external part of the whole story is open source culture. So you can basically, because it's open source, you can just fork it. You can create new features. If you dislike var, who here dislikes var? You dislike var. Okay, so I was working with a team that the team manager disliked var and disliked something else. I'm not quite sure. So basically, you can now take Roslyn, fork it, disable that at compiler level, and ship it inside the company. Well, that's a possibility. Well, let's hope nobody uses that possibility. I'm not giving you any ideas. So, if you want to be part of that community, you can do that in various ways. You don't have to create new language features. You can report bugs. You can suggest new features. You can pull in like new tests, new documentation, documentation fixes. Sorry, and you can also spread the word like I'm doing, just talking about Roslyn. Okay, so let's talk about integration. So the first and most obvious candidate for integrating with Roslyn is the IDE itself, the Visual Studio, because the Visual Studio team is, let's say, near the C# language team. So before, with the old compiler, how would we create language features? First of all, we would have to re-implement a lot of those. For example, ReSharper, even today, has its own parser, its own code analytical service, which takes in a code and creates a metadata, and then you can do stuff on that metadata, like refactoring, searching, advanced analysis. You can do pretty much anything you want after the fact, right? But you have to re-implement that. And when C#6 comes along and C#7, you have to work on that as you go. So previously, even the features inside Visual Studio were tightly coupled to the whole experience. When a new feature comes out, a lot of things have to be changed. And one thing you always have a problem with is that the in-house experience with the in-house tools is radically different than the third-party tools. So the UI looks differently because the third-party components have to redefine and re-implement the UI and for you to use. And that never matches. And we'll see later on that it matches now, as you can see here. So the new interface looks like this. Has anybody seen the new Visual Studio 2015? Not a lot. All my demos will be in the new version, so you'll see everything. So this is a new light bulb. For you familiar with ReSharp, it's the so-called Alt-Enter. Now it's Control-Dot. So it gives you a new editing experience. This is now a unified center for all code-related tools. And it's for in-house tools and for third-party tools. So basically, the Microsoft is now dog-fooding its experience. So whatever they are using, you're also using. This is great for us because we no longer have to implement like the whole scaffolding. We don't have to battle with the UI. And if we won't have a problem with performance because they're using it for their own tools. So we hope that they'll optimize it for themselves. So let's go to the first demo. So one good usage for using Roslyn to improve experience is analysis. So has anybody used FXCop or StyleCop? Or static analysis? Okay, lots of guys. Okay, so FXCop is after the fact. It's a post-build step, which happens, let's say, too late in the process. I was working on a large code base that took a whole night to compile, like 6 hours for both debug and release and all possible targets. So we are talking that FXCop goes way later than we would want to. We want to have feedback from the code immediately. So let me show you a small demo. Here I have a brand new console application. It's not brand new. I created it a few moments ago. But let me just find my mouse. It's missing. It's strange. These things always happen on in live demo. Luckily, luckily I have a keyboard. So what we have here is a simple class that implements the iSerializable interface. You can see the red squiggles indicate that there's an error. Why? Because you haven't implemented the iSerializable. And you can see here that this is the new. And now I have the smart cursor. Let me try it again. OK, so you see the new interface here. Just let me zoom out a bit. I haven't tried with zoom. So what we can do here, we can implement the interface. So this is something that's enforced to us by the compiler, by the language itself. But this is not enough. The iSerializable interface requires additional constructs like the serializable attribute. It requires a special constructor that will be used when they're deserializing. And the language cannot enforce that. You cannot write interface which enforces constructors. You cannot write an interface that enforces attributes. And for that, you would have to either know it or use FXCop as a post-build step that will tell you that you're missing that. Or in the new Visual Studio, you can use something that's called diagnostics and code fix. We'll go into details later on. But how do we get those? So we go to NuGet packages. And because I was afraid that the internet won't work, I already downloaded it. You search for FXCop. And is the internet working? It should be. We're going to get a list of packages that match the FXCop. And the one that we want to use is this one that's already installed. So it's Microsoft Code Analysis FXCop Analyzers. And this is just a short list of the possible analyzers that are already implemented as diagnostics. And you can now see that there is a green squiggle underneath the My class. And if I press Control-Dot or go over to this light bulb, which I cannot because I can't see the cursor, you can see that it shows me that I need. Can you see this in the back? OK, so it's telling me that I need. I can't use the zoom here. Oh, I have this one. It's Windows. Come on. Okay, see that now we can enforce the serializable attribute because this package gives us analyzers which can show us this. And you can see the proposed change in green here. Red means delete, green means add. Good luck to all the colorblind people. If you want to know more about why is this necessary, you can press this link here, which will take me to the MSDN explaining why is that change necessary. You can do that. So I'll press enter. Now I get the attribute. And you can see that there's still a green squiggle. If I press Control dot again, you can see that the new requirement is to implement serialization constructor. And it's also showing me how it will look like after the fact. Or you can also suppress this whole warning if you dislike warnings from the compiler. That's always an option for you. But let's say we like what the compiler is proposing, and we're going to implement that. Okay? So you see now that, pardon, we have 2 additional rules that we can now enforce. So how does that work? When we added the new NuGet package, there's a new node in the references called analyzers. You can see it here. And you have new packages. You can see the names here. So this is the name of the original package and the name of the dependent package. If you open them, you can see that there is a list of all the FX implemented checks that are from the FX cub, now implemented as an analyzer. What you get with this is you no longer have to do it as a you no longer have to do it as a post-build step. You now have a live analysis, which is much earlier than you would get now. So you can use these analyzers to enforce rules while writing your code, which is fine because we always want to get error as early as possible. We prefer compile time rather than runtime. We prefer design time rather than compile time, and prefer real design on a whiteboard before actually writing a code. But who designs code these days? Anyway. So before I show you how that diagnostic works, I'm going to tell a little bit how Roslyn actually sees your code. So Roslyn is a compiler. It also has a tokenization support because it has to parse the code, create tokens from it. And here you see a small sample of code, simple class with a single method, and the comment at the end. And this is the syntax tree with just nodes. So you can see the compilation unit is just a file. You can go more than that, like we create workspaces, but we'll talk about it later on. So you have a compilation unit, which is a file. It has a class declaration, which is class C. It has a method declaration. Method has parameter list, which is empty, as you can see. And it contains a block. Block is everything inside of that. So this is how, if you would use this API from the Roslyn, you could give it this code, and it will give you out a tree that looks like this. OK, so these are nodes. They tell you the high-level structure of your code. But that's not enough. You cannot reconstruct that code from that tree. But if you go further along and you take a look at all the tokens, now you can see that you get end of file for the compilation unit. You get tokens like class. You get the class name. You get all the tokens from the code. But that's still not enough because you cannot reconstruct that file from this tree. But you can reconstruct your file from this tree. This is the full representation of that file, including something called trivia. Trivia are spaces, tabs, basically white space. This allows you, to perfectly reconstruct the original source code. This will be important later on. You can see that there that you have those small characters telling you what the corresponding node is here. You can also see that we have comments. Basically, the Roslyn takes that as an input and gives you this as an output. So how would you see that? You don't want to write that code yourself. So there's a small extension written by the Roslyn team, used by the Roslyn team, and hopefully used by you when you were writing your own diagnostics. It's called Syntax Visualizer. I'm going to show you how it looks like. You can see the source code. It's open source. You can download it. It's available through extensions dialog. I already installed it, so I'm going to just launch it here. Roslyn Syntax Visualizer, and I'm gonna dock it to the right. Okay, so it's empty. But if I touch anything here, you can immediately see the whole file is being represented as that tree over there. And you can see if you take a look at the legend, it will it will tell you which color corresponds to which kind of node, right? So you have syntax node, syntax token, and you have trivia. It works both ways. So if you want to see what corresponds to this mouse doesn't work. If you want to see what corresponds to this particular node, you can select it in a tree and see the corresponding code on the right, or you can always move along your code. This will help you to realize how Roslyn sees your code, because the Roslyn is the compiler that gives you all this access. And you take a look at the tree on the left, you see what you have, and you'll also, for example, if you have a code that looks bad for you, for example, show you not equal exception, how would you detect that? So you go here and see that this entire, let me just scroll down a little bit, this entire subtree corresponds perfectly to this particular code. So you will use this representation in token sense to find this kind of code. You will not search, for a string called show new not implemented exception, because trivia might get in your way. Like you have two spaces and you will miss finding it. But you can use that tree representation to find it. So let's see how simple code fix would work. Let's create a new project. I have lots of samples, so I'm going to just show you how easy it is to create. You also have an extension that gives you new templates for the Visual Studio, which are all located in the Extensibility tab. Please keep in mind that you have to install the Visual Studio SDK before installing the templates, because these are extensions for the Visual Studio itself, so you have to have the Visual Studio SDK first. Okay, so you have 3 new templates. One is a compiler platform console application. That is a console application with reference to NuGet which references the NuGet packages with Roslyn. So you can use Roslyn immediately in the console application. You have diagnostics with CodeFix, and you have the code refactoring. I'm going to show you both ways, both projects later on. Okay, so let's create a simple analyzer. If I press enter, it's going to create 3 projects for me. One is the actual CodeFix and diagnostics and CodeFix project. You get a nice README. You'll get a VSIX project that will package the extension for you. Okay, let me just, sorry for that. So these three projects are created by the template. So the first one, the portable one, and that's a really interesting thing. This project is actually where the magic happens. And it's portable, which means that theoretically, if you want, you can use it on Mono, on Linux, because it works on multiple platforms. You can use it on web, whatever you want. You have a test project, which contains, which shows you how to test the code fixes and diagnostics. It's really fun. And the third project is VSIX. That's a Visual Studio extension. It will allow you to create VSIX packages, which you can then distribute over the extensions and updates dialog. You can use it to install them on Visual Studio level. You also have an option, I'm going to talk a little bit later about that. You can distribute all these packages via NuGet, like I showed you earlier with the FXCOP, which is slightly different and serves as a different purpose. Okay, so let's take a look at the code. At the CodeFix and Diagnostics project. You have Diagnostic Analyzer and you have CodeFix Provider. Those are the 2 files which are the crux of this story. So the Diagnostic Analyzer checks the code for errors or warnings or info, whatever. It checks the code and reports back that it has found something which it considers bad. And then you can offer code fix. Sometimes you can detect errors without offering code fixes. We're going to talk about that later on. But basically, you always have a pair. You diagnose the problem, and then you offer a fix for it. So the basic project that you get when you create a new code fix and refactoring is the, let me just turn on word wrapping, because I don't want to scroll in 2 dimensions. I'm not sure what's your religious status on word wrap. I love it, because I don't have to scroll in 2 dimensions. Anyway, now you can't really see anything. So let me just zoom out a bit. Okay, so the first important thing in the diagnostics is you have to register this yourself. So what you want to find. So the basic analyzer, I think it wants to create everything uppercase. So basically, you want to find symbols. Symbols are class names. And you say you want a name type. And then you register a function, analyze symbol, which will implement. Now, you don't have to go through the code. I'm just going to go through it as if it's a sketch. So basically, you get the context. Context is just a file. You're in a compilation unit somewhere. And actually, because of the way you register, there are quite a few register methods here, you will get a context where you can perform some analysis. You can detect, for example, syntax nodes, symbol nodes. I'm going to show you both analysis in a second. And basically, you extract a symbol, because we're now operating on symbols, class names. And if you can check here is, if the name of the symbol has any lower character, then you create a rule. You create a rule for diagnostics, and you say, well, it's actually in the resource file. You say that this class has a lowercase symbols, and we want to enforce that all classes have uppercase symbols. Okay. So if I were to run this project, I have to set VSIX as a startup project. Let me run it quickly. With what this will do, it will spawn a new instance of Visual Studio with this extension preloaded. So this is not the same instance, because you don't want to work in this same Visual Studio environment. This one is blue themed, that one is white themed, if you haven't noticed. So let's go. Let's take a look at this very simple application. You have a my struct. You see that green squiggles appeared. Let's go over there and control dot. You see make uppercase. So I haven't shown you yet the code fix part, but basically you notice that the make uppercase is part of the same editing experience that native tools are. So basically you don't have to create your own UI. You just say, hey, there is an error here, and you give it location of the error, and then integrate nicely into other pre-existing solutions by either you or in-house or third party. And it will say that you have to make it uppercase. Okay, so now let's go back slightly to a code and to see the code fix provider. Code fix provider is actually, I won't go into too much details, but basically code fix activates in two scenarios. First one is for the preview, that's the green one, and the second one is when you actually press enter. So basically you have again a context that's you are in a document or in a solution. You want to know where exactly in the code you are, like the concrete location in span, like 250 character from to 300 character. Okay, and then you find your location, you find your span where the error actually is, and then you actually reconstruct a tree. This is actually made in this small function. So basically, you take identifier, you make it all uppercase, and then you create. You don't have to look at the code. I mean, it's huge. And one thing I hope that the community or the Microsoft will create a better API, because this is really raw, as if you're writing Win32 applications nowadays. So basically, what the gist of it is that you take a syntax tree. You know where you are. You know what you want to do with that. You change it. You change the tree, create a new one with changes in place, and then you return it back. And so that's the way that this whole project works. Like you first find an error, and then you say, okay, let's replace that part of the code with a new one. And the whole scaffolding inside the Visual Studio will take care of that, and it will show you what you've done in two different places. The first one is in the preview. You can see here the old code, my struct with all uppercases, right? You can see all the changes it found in the file. You can also suppress it. So the default, it's by default. You can always suppress either globally or locally any proposed fixes. And when you press enter, it will again apply the code fix here. And it will actually, create a new file with changes on these two locations, right? If you have any questions, I can take them immediately. So feel free to ask anytime. No questions? Okay. So sure, go ahead.
How does it kind of conflicting rules?
Well, only one rule is invoked at a time. So if you'll see that later on, the green figure later on, you'll see that there are, if you have two rules, you always choose one. So you can apply them in succession, and it's your choice to which one goes first. You never can apply, even if multiple diagnostics target the same piece of code, you only choose one of them. You never apply all of them because of that order, because you never know. Maybe one code fix will fix the next diagnostics, right? You have two in a row, and one will fix both problems, one will not, and it depends on how you actually apply that.
One more. The API that you interact with, it's implicitly thread safe because it's all the weights there.
Yeah, it's always done in the background. Yeah, everything is synchronous. You can see that in the code itself that the changes is done synchronously. See, you call the built-in rename symbol action. This is the default refactoring operation of Visual Studio. And it's designed to work asynchronously because as you type, it has to check all the time, and it has to offer you solutions. But the code fix itself, it's applied immediately. Like you can work on a solution level, you can work on a class level, but it's applied as a unit. It's hard for you to do multiple fixes at a single time because you are still in the UI, right? This part is actually really tied to the Visual Studio. The diagnostics part is not. It can be part of the build process, for example. But this one is actually in the UI. So when you press enter, you can't do really anything until it's over. It's asynchronous just for responsiveness of the Visual Studio, but you really never do two actions at the same time. If anybody has any worries about performance, I mean, the Visual Studio, the project for Roslyn has the solution for Roslyn has 103 projects, and because they are working on dog fooding it, so if they find performance issues, they fix them immediately. So you can rest assured that performance will not be major issue. It will take some toll on your build process, but if you integrate it, but it's not supposed to be any harder than that. One particular note I like to add here is actually two notes. First, you should this default project never checks if you are in a generated code, and you never want to emit warnings in the generated code, right? So they actually have here. They have a check that they themselves use to check if the file is designer file really needs solution, right? Yeah, actually, the guys from the Wintellect, they implemented their own check. So basically, you never want to invoke the check on the generated code because, obviously, you can't really change it. It will change immediately back. The second note I want to tell you about is that this always works on a compilation unit level. It never works on a solution. So you cannot really detect solution-wide errors. So why is that? Because the diagnostics can be invoked as a part of the build process. And because build is parallel, you really don't have a solution yet. So it's hard to reason about what you can do right now on the level of solution level because you still don't have a solution. But you can do something later on. Okay. So I asked previously about var because I have a small sample here. var analyzer. So this is really simple, just diagnostics not without code fix. So you register a syntax node action because var is a syntax. It's not a symbol. It's a C# level syntax node. You register a new action. It's called onDeclared. It's immediately here, and you say that it's a local declaration statement because you can declare stuff non-locally, like class level, right? And you get a model from the context, and you check. So this is something you have to learn. It's not really intuitive. You check if that is var, and then you report the rule. So one thing that this whole project comes with is the resix file for resources. So and the NuGet specifier. Okay, so here you have. I added new strings. So what you really want is always have your diagnostics localized to multiple languages, unless you're working as an in-house solution. Okay, so if we take a look at how that looks in the runtime, you can see here that var has a underline. Really, it hasn't been deployed yet. Let me just destroy it. So imagine if you have two competing managers. One tells you to install diagnostics which forbids the use of var. Another tells you to install an extension which always forces you to use var. Now you have two in tandem. Like it will say you have an error here. What's the error? Use var. Okay, I will not use var. You have an error here. What's that? You should use var. Well, decide. So that's really religious. Even the C# team themselves, they really are not sure which way they should go. For some reason, it doesn't work. When it happens, you can usually clean the cache. I will not do that because it will take me too much time. You can clean the cache for this Hive. It's Visual Studio. When you launch Visual Studio in a separate Hive, you actually give it a new profile, new extensions, and everything. So it's called Hive. You can see that if you take a look at Alt-Enter here, and take a look at the debug, you can see that it launches dev the Visual Studio, and it gives it a Roslyn Hive that you can write anything here, and you can then differ different hives for different project solutions ever. Okay, so now let's talk a little bit about distribution. So there are two ways to distribute packages. One is via Visual Studio extension, another is via NuGet package. So why use one over the other? When you use it as a NuGet package, it's project level, right? So you can enforce diagnostics on a project level, which is great because when you have a large team in a legacy project and you get a new developer, you want them to, well, when I arrived at a certain company, they gave me a 100-page manual on how to write code for C#. It contained instructions on how large the file should be, what was the naming convention, should I use using, should I use var? I mean, of course, I should use using. Anyway, so there's a large manual telling me how to write code, and you never read that manual, right? And now you can actually enforce all those rules when the user clones the repository. When you get a project, you immediately get all the conventions for that particular project, be it naming convention, usage scenarios, or anything else. On the other hand, when you distribute it as an extension, it's global. So for every project you open in that Visual Studio instance. And you should use those diagnostics and code fixes which affect the language, the bugs for themselves. You should install them on the global level, but project-specific features you install on a NuGet package because it's related to the project itself. This, like I said, this will enforce your company-wide policies. You can use your own private NuGet package. There's a repository. You have instructions in the README file how to do that. Like I said earlier, it forces you to conform to a specific style, to use some patterns that are specific for that company, certain idioms. Okay, the last point is something that's really interesting. So previously you saw that FXCOP analyzer, which is something you will want to do. But imagine if you have a library which you wrote, and you have certain patterns that you want to enforce when using that library. You cannot really enforce them. You have a website with documentation, maybe a README file, where you tell you can use it like this. The most thing you can do, you can use obsolete attribute to tell somebody not to use a method, but you can tell somebody how to use a method or to avoid certain scenarios. For example, if you're writing asynchronous code, you should always configure await false in the library. And that's something you cannot really enforce through attributes to anything. But you can write an analyzer which enforces such rules on a global level. So what I'm aiming at is here that you have two libraries, your own library, and then you have, let's say, documentation library, which both are NuGet packages. You can pull in both. One gives you the code, the API. The other gives you environment which tells you how to use that code, which is really awesome thing to have. They call it code-aware libraries because they can not only install themselves like you now have a reference, but they can also tell you how to use such code. Like the FXCOP has FXCOP. That analyzer was written by the Microsoft. But imagine if you have your own public API for whatever, you can write such rules yourself. Because you saw that some rules cannot be enforced at the language level. You have to enforce them in a higher order. A higher order, let's say, environment. So I've already shown you the var analyzer, where you can enforce some rules. But let me show you something really, really complex. So I'm not sure if you are familiar with the SSL bug Apple had last year. So the problem is can you see the problem? I mean, it's highlighted, so it's pretty obvious. You have two GOTOs here. This basically meant that any SSL certificate will pass. and it will be authorized on the Apple device. This code passed the audit process. It was successfully checked in. I don't want to be in the shoes of that guy who wrote that code, but so this is really, really major problem. It's C code, so obviously it has problems. But what I mean, like when I talked about the manual earlier, we had a recommendation to always use braces in if clauses. So can we enforce that? Sure, we can enforce such a scenario. So I have a already made demo. It's called brace checker. Previously it was called brace yourself, but it's not very polite. So if I run that solution, you actually saw it earlier because it was already built in and I didn't delete it. Okay, so let's. You'll see that I have a if and else clauses that have green squiggles because they don't have the. Oh, it's loading. You see that they have green squiggles. Why? Because I detected the code that checks if there are braces. And you can see that it tells you to add braces and or parentheses. It's called parentheses, right? And it works on both else if level and if level. It doesn't work on else level because for obvious reasons. Here you can see that basically you have two competing checks. One is mine, the add braces one, and the second one is unreachable code detected. Come on, I cannot use the keyboard. So you can see that I already showed this earlier, but just want to stress the point that the built-in functionality by the language team, by the Microsoft, can be easily composed with your own diagnostics. So how is that done? The code is rather simple. So I'm gonna show you. I'm searching for a keyword. Okay. So what we want to find, we want to find a syntax node. Which one? We want to find the if statements and the else clauses, right? And then we have the method that detects the problem, which is rather short. So we check if this node where we are at, because we are at syntax node level, if this is an if statement, okay. If it's really if statement, right? Because we have as. If it has a sub-statement, because we are still writing the code, we should not throw errors here. And we have to check if the sub-statement is a block. If it's a block, we're done. The developer wrote the correct code. But if it's not a block, then we say, okay, you have a problem here where at the if level, and we'll give it some description. Otherwise, if this is an else clause, we do the same check. But we ensure that it's an else if rather than else. Okay, because if else, you know how else if works, right? It's else if it's a substatement completely. It's not else if. It's not never the same. No, they're never in pair. Okay, so it's basically the code is the same inside the detection code, but you always tell it where it should display the squiggles, and it will show it. And the code fix is also simple. Okay, so basically, first you have to find the location. This code will be pretty much copy-pasted. And then you check this token where you are at, because the diagnostics has been invoked. If you are if keyword, then get a statement. And then what do you do? Now, take a look at this. It's immutable code. You take an existing if statement, and you create a sub-statement, which is a block, because you want to add parentheses. And you nest inside that block the previous substatement. So you had an if with a substatement, and now you enclose the substatement inside the block. So basically, all this is immutable. You always generate a new tree, which you give back to the Visual Studio, which will then replace it, etc. Everything is always immutable inside the Roslyn, at least at the surface level. So when you are done, then you get a new if statement. You take existing and close the substatement in the block. You also say, tell it to respect the formatter. This means that everything will be aligned. Without this, you will get a really strange situation. And then you tell the root node, the root is the document itself, to replace the original if statement with a new if statement. And now you register the code fix to the environment, tell it add braces, you give it the result. I use the task from result because it's asynchronous by default. So you can all condense this to three things. Where am I? What I want to change, and then tell it I changed that into this. Okay, so that's the whole the whole diagnostics thing. And now we have a solution for the C problems, right? So you will actually get an error, and you would you get a warning, and then you would respect that warning and change the code. And then you would probably, if you would put brace parentheses around this line, you would probably notice that this go to fail hangs in the middle of nowhere and probably should be deleted, right? And because this code fixes diagnostics can be invoked as part of the build process, you can actually send notification, fail build, whatever you want. Okay, any questions?
So every time you type any character, are all rules executed?
Not all the rules. Let me just show you this register method. This is the important part. You see, there are different. So, because the Roslyn exposes a set of interfaces, you decide where you want to plug in. So it exposes different. Oh, you don't really see this. Let me just zoom in a little bit. Do you see it now? Okay. So you can tell it when do you want to be activated. And then you actually, and you also saw that I told it to only check the if statements and the else statements, so it will not check the try, catch, other syntax statements. So this means that only I'm invoked only when I satisfy certain rules. For example, the whole, let's say, class of tokens, the token syntax tree symbols, and then on a particular subsection like if clause, if statements, right? So you are invoked only when you type that code for which you registered.
What happens if you have some code, you commented it out, then you modify the comment part and uncommentable thing again? Will it?
Yeah, it will reevaluate it, and it will also evaluate all the rules on when you create a new file, when you start a project, when you open, add existing project into solution. It will reevaluate all the rules on the new code. Yeah, it works that way. So you saw that when I started the new solution, opened the previous project, it already showed me all the green squiggles immediately, without me writing anything, because it has certain events when it's invoked, and it's always invoked when you create a new class, add the existing class, all those solution-wide, project-wide actions.
Okay. One question about language.
Yes. Okay, so
Obviously, since I'm writing VB and C#, some of the things I do would be identical in both. Some of the things like braces would not be. Can you write your rules language agnostic?
Yeah, you can. Some subset. I'm not really sure which one. They told us that there exists a subset which is because it's underneath is the CIL, right? So there are certain code fixes where you can check like on the not IL level, but it's on the syntax level, like higher up, and those are language independent. But things like braces, they are definitely language dependent because you don't have those in. I'm not really sure. I know that it can be done, but I'm not sure if I can show you because I'm not really sure myself. But that's something they actually talked about because certain things are, for example, the serializable attribute. It actually is language.
My favorite case is the suppressed message. We want justifications.
Mm-hmm.
That sort of requirement is independent of the language.
Yeah.
The implementation may be slightly different. So,
yeah, on the next slide, I have a list of popular repositories showing different code fixes and diagnostics. And one of those is funny because it enforces that every file has an open source header, like documentation who did this file when, and so you can enforce such things like which are, let's say, even language not related to the language itself, but to the code, like to the namespaces, to the organizational look and feel. Yeah. Okay, so it is possible. I'm not really sure how. Okay, so since everything is done asynchronously, so the performance penalty should be minimal. There is a great blog post by Eric Lippert a few years ago where he actually talked about how they solved this problem with the synchronous code. When you are typing your code really fast, it has to evaluate all the rules, and then it has to stop evaluating because you change the code and you're typing really fast. It's really fun, and it's actually something they worked really hard on. So you shouldn't be worried about you should be, because it will affect performance. Let's say it will be just a slight, because it's done in the background, right? So I think that this will convince you that some certain issues are really large, and code fix for this you might want to use as an extension. Or if, for example, misusing of using should be global. It shouldn't be project specific, right? So what can you really do with it? There are quite a lot of different things. For example, you can find errors in your code. For missing using, you're instantiating disposable class without using it. Maybe if you want to enforce, for example, constants, vars, you can enforce style changes. For example, that every class begins with a C or does not, which will show it in the error output. You can do some static analysis, like the fxcop example showed. You can also work on patterns, like you can detect the whole class level issues, like if you are using a field properly, if you have a some pattern inside the largest block of code. You can also do data inspection. This is really funny. If you have, for example, have a string with JSON inside it, you can actually inspect that JSON, see if it's well formed. If you have hex colors, you want to notify yourself that this hex code is invalid. Like you have one extra character, or you have one character too few. You can detect connection strings, is equal. I have a list here. Let me just see. I forgot to open that folder. I'm not really sure where I opened it. Sorry for that. I have we had at the summit we had a hackathon. Who will write better, code refactorings, and there are a lot of good ideas like detecting XML errors inside the static strings. Detecting invalid patterns. It's really funny. Once you put your mind to it, you can find out quite a lot of things can be detected at the right level, the right level and right level, right? So an additional thing, other than the code fix and diagnostics, are refactorings. So diagnostics are something that you use to diagnose the code to see if there are errors. But refactorings are silent tools. Why? Because refactoring is something you might do, but it's not really enforced. For example, you might, if you have a var x equals 1, and you never change that x, you can tell it, hey, you can change that to const, and that's code fix, diagnostics and code fix. But if you want to, for example, have a, if you have extract interface, or you want to create a new class, you use refactorings. Why are they silent? Because they don't appear in the UI. They're actually invisible. So I can show you a small demo here. Let me just, my mouse is never working today. It's here, there it is. Have I started it already? Okay, so you notice, okay. So if you take a look at the struct name, it's called my struct. It's now uppercase because of that change I made a while ago. But for example, if you want to reverse the name of this structure, that's the default refactoring, you see that there are no squiggles around it. If I press Control dot, they changed the shortcut, it was previously Alt dot, you can see that it offers me a change. It says reverse type name, and it says my struct to TCURTSYM. That's a sample, like I told you. So these refactorings are invisible in the sense that they will never expose themselves through the squiggles. But you can certainly do them on a class level, struct level, whatever level you want. And syntax node, symbol node, you name it. How do they work? So you saw that earlier. I'm going to show you anyway. There was a second type of project called code refactoring. And if you create a default one, it's here. Let me just simple code refactoring. Okay, just let me close this one. You can see that I have two projects. One is portable, one is VSX. I don't have the testing project now. Let me just move to this. And VSX is again a running project and also packaging because you get extension. All the code is in the code refactoring. So code refactoring it also operates on the similar level as the diagnostics operate because it's the Roslyn interface, right? So you can use it to. Am I showing the right code? Yeah. So you can use it, use the same interface to find certain things, and you can apply them. Apply them when you want them, because you hear that we create a code action. It's not code fix, it's not diagnostics, it's actually code action. You have an action on that code level. One problem that I have with these refactorings is that they are silent. You never know if you have them available. So if you take a look at your project, you open the file, you're not really aware, can I do something with this? You have to guess, press control dot everywhere to see if something is exposed. They have their usage. Like I said, you can enforce patterns, you can implement stuff. But I think that the shining star of this entire Roslyn is the code fix and diagnostics, because they're more into your face. They tell you that you have problems and they tell you how to solve it, which is always fun. Okay. Any questions about this? I'll show you the demo. So if you want to see further examples, the Roslyn comes with a set of samples. They come with, for example, the asynchronous code detection. They tell you if your asynchronous method does not have async suffix. It will tell you if you're returning void, because asynchronous void methods are evil. And a few other samples. CodeCracker is open source initiative to collect all the useful code fixes under one roof. You can submit pull requests to them. There are also analyzers made by Wintellect. They are a consulting company that worked on quite a few interesting things, and they also have a whole list of analyzers they wrote, which is so if you want to see what other people have done and to maybe see if something interests you, if some of these analyzers are something you would prefer to have in your project, so that you fix those errors, then you can take a look at such projects, which is also good as a learning purpose. Okay, now, next topic, which is actually my favorite topic in the whole Roslyn universe, is scripting. So anybody here uses a language with REPL? F#, right? Yeah. So REPL is awesome. A long time ago, September 2011, when there was a public CTP of Roslyn, they had a C# interactive window inside the Visual Studio, which allowed you to basically like F# interactive. You could actually test your code on the fly. Scripting is really, really cool. So why would you use it? Well, why not? Sorry, it's just too good, and I don't really have a good explanation why. It just is that good. So you can create a REPL-based tools, so you can test code in isolation. If you want to install it today, you can just go to the Chocolatey and you can install script CS. That's a scripting environment at the PowerShell level, and you can write code and test it. Like it's a REPL loop. REPL stands for read, eval, print loop. So basically, you write code and get an output immediately. Another cool usage is to embed scripts inside an existing app. So why would you do that? Maybe if you have a printing facility, you don't want to create your own DSL or use VBA or whatever, you can actually use C# as a scripting language inside your larger application, because that scripting language, the scripting environment can have a surrounding environment. It can know where it's located in. So it's not just you have a small piece of executable code. You actually can integrate it with a whole surroundings, which is quite awesome. And you can also write, for example, write scripts that can simulate entire environments like script CS does. It can create small websites, and you can test them in a really fun manner. So how do you use it? There's a C# script class, which you just give it a code, right? It will evaluate it, and the result will be a script state class, which will contain a return object. Some statements obviously have no return statement. This one evaluates to 200, right? And you would get 200. Okay, so how do we use that? Unlike the previous tools you can use with Roslyn, this one doesn't have a NuGet package. So what you have to do, you have to go to a Roslyn repository, download it, build it. It will take some time. And once you're done, you'll get a whole set of libraries. And there are 6 or some sort of that classes which you have to copy into a target solution, and then you can use it. Okay, so let's see how we can use it effectively. Because we never want to use it non-effectively, right? Here you go. Just a small distraction. When I talked earlier about the integration between the new language features and the IDE, there is a cool new tool inside it's called rename. If you press F2, it will offer you to rename stuff, right? But the C#6 introduces a new keyword called nameof. So you can basically say var main equals name of main, right? Okay, so now the result of main will be main in string. And this main is now a symbol. And if you have two teams, one team does the language features, another does the ID feature, and the refactoring tool, if it's not coupled tightly to the compiler, you have to reinvent your own parsing of this new feature, right? You have to guess this is a symbol equivalent to this symbol. Those are the same symbols, right? And you first have to wait until they decide on the syntax. You have to, re-implement that exact parsing behavior. You have to, guess that that's the real intention, that that's semantically the same thing. But when the same compiler is used for everything, for ID features and the language features, when I press F2, okay, it will not rename. I cannot rename this element. Well, probably because unresolved conflict. Really. Let me just try static void foo, the obvious method name, right? Foo. Okay, I cannot rename it. So I guess my example failed. Anyway, I'm pretty sure it worked in the previous TP. I think this is actually regression because one of the examples I shown in the previous conferences was that when I talked about new C#6 features was that because of the name of, you can write view models better because now you don't have to use the name of the property as in string or use a lambda. If you have written XAML code, you have to write view models with notify that they're changed. So now you can use name of, and when you press F2, you rename every instance of that symbol. And I'm pretty sure it worked. So this is actually regression. So this is just a small point to why integrating everything is really important because you get side effects, which are actually nice in this environment. Okay, back to the scripting environment. Let me just start this project. I have three different cases. Let's try test 1. Okay, you see the code. I tell it to run 1 + 2, and the result will be, anybody knows? It's 3, actually. So we can prove that it works. Okay, so let's try test 2. Test 2 shows you that you can feed the previous, okay, so I have a result here. And I run it, and I give it the previous result. First time it's null, then you have a feedback loop. So what does this give me? It allows me to continue as a REPL in the same environment. So let's run this one. Okay, now let's go. Okay, so let's say var x equals 10. Okay, x, 10, x + 1. Okay, so when is this useful? Let's say system dot date, new date, or let me just use this one, date time dot now string. Cool. Now I can play with it. Okay, now this gives me this. I want the whole year. Okay, you see the point. You can try out the code. You don't have to create a whole new project. This is also useful when you are, for example, if you have a small API which you've written and you want to test it immediately, you can use these kind of tools to test your code immediately. But how can we do that? This code lives in, you can only use C# stuff inside. To use the outside world, let's take a look at the third sample. I hope that I'm not pronouncing really. Get away. Oh, remind me later. Please, just go away. Let me just go kill the presentation. Okay. Remind me later. Okay. Sorry about that. Java, everyone. Okay. I have to. You see the demos, okay, the slides, okay, now you. Now you see it. You saw it. No. Simple samples. Okay. So the test tree, I'm hoping that I'm not pronouncing that wrong. So I gave it globals. This is a really simplified sample. So I gave a new instance. I have the classes down there. You can see that it has two public fields. No, that's good, but still. And I initialize those fields to x1 and y. And I will run the code x plus y. I really like to keep my samples in terms of addition of single-digit numbers. You know, it keeps the audience. You never want your audience to feel lost. So instead of you never want to feel them lost. So let me just fix that. Test 3. All of these APIs have a lot of tests, unit tests, inside the Roslyn repository. So if you want to learn how something is done, 1 + 1 is 2, right? So you can pretty much take the repository, build it, and there are like tons of testing projects, and you can just see how they use it internally because they are really thorough at testing. That's how I learned how to use scripting, because I saw their sample, and I didn't copy paste it. I wrote it. You know, I looked at the other screen and just I copied by hand. Anyway. So, okay, so this is rather simple. Let me show you a slightly more complex sample. This project was actually built a long time ago. This project, you can find it on GitHub. It's called FastSharp. I named it, that's why. So but the idea is that you have a scripting environment that you can quickly evaluate stuff. So basically, you can write var x equals 10, press Control Enter. It will output. You can see that it doesn't have a output. Press Control Enter. You can see the output is 11. Is x equal to 11? It's false. No, it's equal to 10. It's true. Can you see the bottom? Yeah. So basically, the idea is to have some sort of like a SQL management studio just for C#, so you can quickly write small scripts and test them. So you can take a selection and execute. You can either execute everything by pressing execute all, which gives you an error. You can get errors. So basically, you can create a whole editors. And notice that this control that it shows the code, it's Avalon Edit. It's really good. It's an open source control for the what's the Sharp Studio? There's an open source IDE that uses this component as a building block. So when you think about how they did the syntax highlighting, they had to write their own parser. And now you can actually use C# parser. I'm going to show that in an example in a few moments. So if I want to create my own scripting environment with my own syntax highlighting, instead of writing all the components myself, I can actually reuse most of the Roslyn and get away for free, right? So this is one more, let's say, advanced example. So we call this compiler as a service because you use a compiler as a service. Okay, go.
The scripting stuff, can you use linking or is it just?
Yeah, you can use everything. Yeah, asynchronous stuff is also supported. Sure, go ahead. No, that's the problem. So the question was, can you run it in a sandbox? If you want what, collectible assemblies, so you can unload the code or reload it.
But if you're going to be allowing users to write their own scripts within your application,
You have to do it on your own, like either whitelisting, blacklisting, or using CAS. But basically, the sandbox is it's the same app domain. You have to compile code to the bytecode and load assemblies. It's complicated. It's something they are looking into it because most of the people actually want so-called collectible assemblies, which allows you to write the code, load it, test it, unload it when you change it, and basically have a code that's changeable. And that's something that's not possible with the scripting API nowadays. But if you define a method inside the tool and you define a new method with the same name, it will overwrite it. So it's still good in that matter, but it's not really sandbox, right? Any more questions? Okay. So compile as a service scenarios, ASP.NET WinX. Has anybody seen that? How that works? So it's awesome. We write code, Alt tab to browser, press F5, no compilation required. Why? Because they have a file watcher that watches the file changes, and when its file changes, they rebuild everything in memory and serve that to they unload the app domain, reload it again while you press Alt-Tab, and then you basically have, unless you have two screens, sorry, and then you basically have your compiling done on the fly instead of, there are no DLS on the disk, they're all in memory. Until you deploy it, then they're actually on disk. There is a cool project called C# Open Objects. The person behind it, it's an idea that you can write code. I suggest that you take a look at the video. You write code in Visual Studio, or you run the code, and then go back to Visual Studio. And while the code is running, you change the code. And the code will change the output in the console. Like, it's freaky. You change the code in Visual Studio, it's immediately affected either in the browser, if in case of ASP.NET, or in the console in case of console application. So it's really, really cool idea. You also have script CS, which I already talked about. This allows you to use REPL on a PowerShell level. You can create MVC project in a matter of seconds. It's great for scripting purposes. You have C#pad.com. It's like JS Fiddle, just for C#. It's supposed to call C# Fiddle, but never mind. And you can also modify code in post-build this. So the idea behind Roslyn is not to allow you to create your own language features, unless you want to fork the code. Like, you cannot create like new keywords inside with attributes with DLS. But what you can do is you can create a post-build process, or actually pre-build process. You can actually change the code. You can write one piece of code in the editor, and when you press compile, it will actually be translated to something else. Like, it will generate a new version, and that will be compiled. Like, that's better than IL weaving. Has anybody used weaving in post-sharp? Weaving is when you take a DLL and change it. Like, for example, if you've written, I notify probably changed interface in your life, you know how cumbersome it is. So you can actually do it as a post-build step. You can actually take a basic plain object class and weave in the new features like logging, like exception handling, validation, contracts, whatever you want. It's called aspect-oriented programming. So that's something you can do on your own, but Roslyn is actually more on a code level. It's not on a metadata level. It's not on an IL. It doesn't allow you to create new features. For example, people want to do meta programming with it. It's not supposed to be that. It's supposed to be just a compiler for the regular C#. Just for you to know that about. Okay, so code-aware tools. This is a section that's slightly has less audience, but it will affect you one way or another. So now that you have Roslyn exposed as services, now you can use those services to build tools on top of it. For example, I've shown you the Avalon edit control. It wants to, if you want to syntax highlight the code, instead of writing your own parser, your own highlighter, you can actually use Roslyn. I'm going to show you a sample with that. You can also replicate code for ID experiences. For example, if you're using Sublime, you want to write C# code, you want to have IntelliSense, you want to have navigation, refactoring, code length, any feature and every feature on the whole level of C# project, you want to replicate it in another IDE instead of holding it inside Visual Studio. And you can do that. There's a tool called OmniSharp. Anybody heard of OmniSharp? Yeah, OmniSharp is a server that's launched in the background, and it serves as an IntelliSense provider basically for your code. So you can use OmniSharp to integrate IntelliSense into Atom, Sublime, Notepad++, whatever your custom IDE. So you can basically build services on top of Roslyn. There are some examples. Roslyn.io is a service where you can create documentation for. It's not documentation. You take your code and put it online, and it will be all cool and highlightable. Let me show you how it looks like. Roslyn.io. I'm already. Not really sure I'm not sure what's the correct link. Basically, if you want to put your code online, like if you want to put it in a browser and you want everything to be linkable, like if you press if you click on type name inside the code, you want it to link back. Basically, like a reference source for the .NET online, you can use such tools like. It's always the wrong name. So you can use Roslyn to build up a document HTML representation of the code. There is a project company creating semantic difference when merging. So if you take, if you want to merge code, you want to see what's changed. Basically, what you have nowadays, you have just changes in on a token level. Like this line has changed, this object, this text has changed. But semantic diff will tell you you added a new field in your class, or you renamed the method, like you have a semantic overview of what your changes are, right? So the other things you can do with it is formatting, coloring. Basically, this is still fresh because the Roslyn has not been out for long and it's constantly changing API. But basically, you can do custom tools. So let me show you an example. These tools are actually my own, but you can find them. I'm really missing cursor. So I showed you earlier in Visual Studio that syntax visualizer. So I wanted to have that on the web so that you don't have to fire up Visual Studio. And if you write some code here, for example, public class, my class, you can see that I've used Roslyn in the backend as a backend service I send to that service this code as text, right? And it sends me the information about that code back. And I can, if only I had. Okay, so I don't have a cursor, but I clicked somewhere. And you can see that I haven't completed this project, but basically you can use Roslyn inside of web service to do all sorts of interesting things. Like, for example, analyze the code to see what kind of nodes exist. And this is just a web port, let's say, of that syntax highlighter. Another example is if you want to copy-paste your code inside a PowerPoint presentation or email, how would you do that? And you want syntax highlighting, you want a console as font and everything like that. One solution is to use a Visual Studio, but depending on your team, I prefer dark theme. Not sure if anybody uses, or Sublime Dark actually. So when I copy-paste that in a white-based presentation, my code is in black scheme. So I want to have a better scheme. So if I created this small tool that will do two things for me. First one is called syntax highlighting. You can see that I can copy paste this inside PowerPoint, mail, wherever, and I will get a syntax highlighting inside the target, inside destination, Word document, PowerPoint, whatever. You can also embed this this HTML to get the syntax highlighting, and you also notice that my code is irregular. I don't have a tab. The parentheses are in the wrong place. This actually do formatting. So how do I do that? If you take a look at the code, let me find. Not that one. I'm sorry, I have to turn off the presentation because I've lost my cursor. Okay, there it is. Okay, so there is syntax tree visualizer control. You can see that I get a text. I use parse syntax tree method of the API. I get a representation outside as a tree, and then I do something with it. I create a JSON representation which I can return to my service. So basically, this is Roslyn used in a web service, right? So you can do this for your ideas where you want to analyze the code. Another example is convert to HTML. Just a second. It's all over the place. It's C# to HTML. Okay, see, I created a custom workspace. So workspace is on a much higher level where you have projects and solutions and folders, whatever. I create a fake project, fake file, and then I put all that code that came from the web service, right? Put it inside that new fake file, and then I classify it. And classification will tell me which span of text is what. Is it a class? Is it a symbol? Is it a name? Is it, it will tell me everything. And then I can reformat that and bring it back to my particular implementation. But again, this is all Roslyn used in a library which is consumed by a web service. So imagine you can do this as a post-build step. Like you can create documentation for your code as a post-build step by using Roslyn APIs, right? And on a further note, I also wrote the small web-based REPL tool. So you take a look at the two windows on the right. So one will, there's an output, there are errors or warnings. So if, for example, I will say var now time.now, it keeps telling me when I type what's the problem. There is no syntax highlighting, but still. Okay, it will do this. Let me write .to. As you can see as I'm typing that it keeps reevaluating my code, right? So this gives you an idea how to use Roslyn to create your own REPL services. This is done differently than the fast sharp example. Why? Let me show you that in a second. Simple expression compiler. You can see that I got diagnostic here, but never mind. So I create a new memory stream, and I emit my compilation unit. Compilation is something used that Roslyn gives me. I give it a code, it gives me a compilation unit, and I emit the resulting code into memory stream, and then I can actually load that assembly. So I can load assembly from a stream, right? Stream is a byte code. And then I can just find the specific, because I gave it a particular implementation, I can find via the reflection, I can find the class, find the method, and then invoke it and show the results back to the user. The only reason why this thing is not public is because what if somebody writes while true? I don't know how to handle that. It will break my website. So basically, this gives you an idea how to use a compiler in the C# level. Oh, we are almost done. OK, so I'll try to run presentation without breaking my. If you want to see how that works, it's all open source. There are links. I haven't provided a link for that, but I'll put it in the slide. OK, so no, you're seeing the wrong version. PowerPoint. Yeah. OK, so some takeaways from this session. So Roslyn is present in the entire tool chain. From the moment you start typing your code to the compilation, to the entire ID experience, to the post-build steps, any integration on the build servers you can do with Roslyn. So in a sense, you'll use Roslyn no matter what. I mean, unless you're still on the earlier version of Visual Studio. But if you're using the latest version of Visual Studio, you will have it by default. You may may not notice it, but the tooling will probably be better for you. You don't have to to see it to use it. But if you want to go further, if you want to create the diagnostics for a tool, create some custom tools for your team or company, you can do that. And I'll show you some samples on what can be done. And frankly, I think that the ideas, the good ideas for Roslyn are yet to come, because the API is still raw. The possibilities, we still don't have idea what to use Roslyn for. But that might change in the future because people will start using it more and more, and some better tools will come along. Maybe you can use Roslyn to create, for example, transpilers to JavaScript. That's a project that actually exists, to take C# and XAML and create JavaScript and HTML5. So you can use Roslyn for that, because you have all the necessary information about the code inside your running code, right? So basically, that's all I wanted to show you today about Roslyn. If you have any questions, I'm still taking them. Okay. Well, if you don't have any questions, then I'll have to thank you for your presence and hope you enjoy the rest of your conference. That it matches now, as you can see here. So the new interface looks like this. Has anybody seen the new Visual Studio 2015? Not a lot. All my demos will be in the new version, so you'll see everything. So this is a new light bulb. For you familiar with RSharp, it's the so-called Alt-Enter. Now it's Control-Dot. So it gives you a new editing experience. This is now a unified center for all code-related tools. And it's for in-house tools and for third-party tools. So basically, the Microsoft is now dog-fooding its experience. So whatever they are using, you're also using. This is great for us because we no longer have to implement like the whole scaffolding. We don't have to battle with the UI. And if we won't have a problem with performance because they're using it for their own tools. So we hope that they'll optimize it for themselves. So let's go to the first demo. So one good usage for using Roslyn to improve experience is analysis. So has anybody used FXCop or StyleCop? Static analysis, okay, lots of guys. Okay, so FX copy is after the fact. It's a post-build step, which happens, let's say, too late in the process. I was working on a large code base that took a whole night to compile, like 6 hours for both debug and release and all possible targets. So we are talking that FX copy goes way later than we would want to. We want to have feedback from the code immediately. So let me show you a small demo. Here I have a brand new console application. It's not brand new. I created it a few moments ago. But let me just find my mouse. It's missing. It's strange. These things always happen on in live demo. Luckily, luckily I have a keyboard. So what we have here is a simple class that implements the iSerializable interface. You can see the red squiggles indicate that there's an error. Why? Because you haven't implemented the iSerializable. And you can see here that this is the new, and now I have the smart cursor. Let me try it again. Okay, so you see the new interface here. Just let me zoom out a bit. I haven't tried with zoom. So what we can do here, we can implement the interface. So this is something that's enforced to us by the compiler, by the language itself. But this is not the purpose of compiler. We can just work in Notepad, right? We can just write code as a text, because that's what the code is. It's a text. Those are text files. You can use compiler to create object files and later on executables. But of course, we're not writing code in Notepad. Some of us are writing in Sublime, but that's another story. So the real reason for Roslyn is because the whole environment, the tooling around the language is really important. It's not the language that works for you. It's actually the tooling, the debugging, the editing, the whole experience from the first line until the deployment, and later on, if you take into account ALM. So the Roslyn is supposed to change the whole infrastructure. If you take a look at the following list, so if you take the first and most obvious thing for a compiler to do is to incorporate new language features, right? And then you want to use those features in your favorite IDE. You have to use coloring, syntax highlighting, formatting, editing, navigation, refactoring. So basically, you start from a pure language, which is text, and then you go up and beyond, and you realize that that's actually the compiler can do everything inside of that. So that's the reason for Roslyn. When it was a black box, so the old C# compiler was written in C++ and a little bit of managed code. So in this step, this magical step, where it creates code, it creates a lot of metadata, which is then promptly lost. And that metadata is really important. Why? If you take a look at what services are now part of the compiler platform, when you open Visual Studio and when you open a C# file, what do you get? You don't get the pure text. You get the syntax highlighting. This syntax highlighting comes from a component that parses the code and produces the output, which can be colored, right? So you have to tokenize it. If you ever took a computer science class where you have to create your own compiler, you know how cumbersome it is to take a language and create a parser for it. And when you take a look at the third-party editors which can do syntax highlighting, like Sublime, like Notepad++, or pretty much any editor that can parse and display C# in a colorized format, it actually has to re-implement the new language features. So when you get a new language feature, you have to redo all the components that depend on it. You have to change the refactoring. You have to change the coloring. You have to change the formatting, navigation, analysis. Everything that is tied into a language now has to be changed because you added a new feature. A few years ago, okay, hi everyone. My name is Tony, and today I'll be talking to you about the new compiler from Microsoft called Roslyn. So I already asked that question, but more people came in the meantime. So how many people have already heard about Roslyn? Used Roslyn? Okay, well, small number. Roslyn, so probably know something about it, but I'm going to have a small introduction telling you about what's the rationale behind why do we have the new compiler. Then I'm going to go jump into scenarios for using it. This talk is intended to show you the benefits of using Roslyn, even as a consumer, and then as a producer of Roslyn-based components. So I'll just give you an overview of all the things you can do. I will not, there will be demos, but I'm not going to code anything because my sacrifice to demo gods was really short, and I don't want to, copy paste anything wrongly. So I'm just going to show you the demos, and they'll work because I tested them. Anyway, so first things first, what is Roslyn? So the basic, just a small side note, it's no longer called Roslyn because Roslyn was the code name for the new compiler. Now that it's done, it's no longer called Roslyn. It's actually .NET compiler platform, so this is kind of deprecated. But still, it's shorter, and we like shorter things. And you can notice the Microsoft naming convention right there. So what is Roslyn? To put it in plain terms, it's a compiler for C# and VB. It's a brand new, and it's open source. It's published on GitHub. It was previously on Codeplex, and it's under Apache license, which means you can just fork it, do your C# or D#, whatever you want to create, and you can just use it as you want. It will be present in Visual Studio 2015 if anybody has downloaded the new CTP and actually any version of the Visual Studio 2015. You have already used Roslyn, so basically. You haven't noticed really anything. Okay, and the one final thing, that Roslyn is a compiler service, but we'll get to that later on. This whole talk is interconnected, so I will tell you things in advance and then go back to it because it's all really interconnected. So first things first, why do we need compilers? We need them to take code and create executable code, right? So if it's just a black box that you see when you press F5 or F6 or you invoke it from the command line. So if that's the real, I was working on an article for a new C++ features in C++ 11, I think. And the Microsoft, because there was a conference, they published a new CTP for the Visual Studio. And it had new features in the language, like a ranged for loop, that's like for each only in C++ world. And the funny thing was that it was implemented in the compiler. You could write code, it would compile, it would work. But the editor showed you that that's an erroneous code. It highlighted it in red, said you cannot write for that way, it's wrong. So what happened there? The IntelliSense was not written by Microsoft, it was outsourced to an external company. And because they were out of sync, first they invent features, and then the IntelliSense team gets there and writes the IntelliSense. So those two components are out of sync, one comes before another. And with Roslyn, you get that in tandem, right? So when you have a new C# feature, it works out of the box. It works magically. It integrates with the rest of the environment. I'm going to show you a demo of that later on. So basically, while the language evolves, you want the tooling to evolve along with that. So this brings us to a real definition and the reason for Roslyn. It's a completely revamped compiler infrastructure. It's not just a compiler, like taking source code and compiling it. It's a complete pipeline from the moment you start your IDE until you get your code and beyond. When you have features like edit and continue, you have debugging, and everything is tied into a language which is tied back into a compiler. You can see that this whole mess is actually just one huge thing, which is then partitioned into services. And the best thing that it's open source, and this gives you some, let's say magically, cross-platform features. If you take a look at the Mono project, they had to write their own compiler, their own linker, jitter, everything. But now they can just take Roslyn and they can get advantage of the new language features immediately, but they don't have to invent them as they see them. Okay, so why would we do that? Who's the immediate beneficiary? Well, all of us. So every developer benefits from a new compiler, because if you're working on a daily basis with C#, you will want new features, you'll want better tooling, you'll want the whole ecosystem. That's of course if you are using the latest version of Visual Studio. For those stuck in Visual Studio 2008, you're missing out the whole playground. So basically, everyone is a beneficiary of this. And then the partners, the third-party people who are building third-party tools like ReSharper, Code, or any other tools that might integrate into your coding experience. Then you have the initial teams that actually work on the C#. When they create new language features, it's now far more easier to add new language feature than it was before. That's actually one of the primary reasons why they chose to rewrite the entire compiler, because they couldn't add new features. It was a whole mess. And now you can see that the C# 6 comes with a whole set of small features, and C# 7 will come with even more and even more. And one external part of the whole story is open source culture. So you can basically, because it's open source, you can just fork it. You can create new features. If you dislike var, who here dislikes var? You dislike var. Okay, so I was working with a team that the team manager disliked var and disliked something else. I'm not quite sure. So basically, you can now take Roslyn, fork it, disable that at compiler level, and ship it inside the company. Well, that's a possibility. Well, let's hope nobody uses that possibility. I'm not giving you any ideas. So, if you want to be part of that community, you can do that in various ways. You don't have to create new language features. You can report bugs. You can suggest new features. You can pull in like new tests, new documentation, documentation fixes. Sorry, and you can also spread the word like I'm doing, just talking about Roslyn. Okay, so let's talk about integration. So the first and most obvious candidate for integrating with Roslyn is the IDE itself, the Visual Studio, because the Visual Studio team is, let's say, near the C# language team. So before, with the old compiler, how would we create language features? First of all, we would have to re-implement a lot of those. For example, ReSharper, even today, has its own parser, its own code analytical service, which takes in a code and creates a metadata, and then you can do stuff on that metadata, like refactoring, searching, advanced analysis. You can do pretty much anything you want after the fact, right? But you have to re-implement that. And when C#6 comes along and C#7, you have to work on that as you go. So previously, even the features inside Visual Studio were tightly coupled to the whole experience. When a new feature comes out, a lot of things have to be changed. And one thing you always have a problem with is that the in-house experience with the in-house tools is radically different than the third-party tools. So the UI looks differently because the third-party components have to redefine and re-implement the UI and for you to use, and that never matches. And we'll see later on